Shiny today. And this one, like the first one, will be quite interactive. But we're going to introduce Shiny dashboards near the end. But mostly I kind of want to just review what we did last time and reiterate it all, okay, so that we can hopefully start to feel more comfortable with it. Before we get into any of that, though, I do want to review Lab 3. So we'll go over all of that. And then we'll talk about Shiny Basics again, getting started, just like we did last time. We'll review some layout options from there. So we'll do tab sets and navbar page. And then I'll introduce Shiny Dashboard. That's going to be pretty brief because Shiny Dashboard is basically just an extension of Shiny. It's just an alternative sort of look and feel of the entire thing. And then if time allows, which it probably won't, but I included some additional slides on reactivity. I just uploaded those today, so like right before class. So if you haven't polled recently, your slides are probably out of date. So if we have time, we'll get to that. If not, we'll cover that on Monday, which was my original plan, but I just threw them in here just in case we have time at the end of today. Okay, so learning objectives today, hopefully you will solidify your understanding of the UI server relation, the way they sort of talk back and forth to each other. And then hopefully you'll be able to create at least tab sets and possibly a navbar as well. Okay, and then similarly be able to create basic Shiny dashboards, and we'll just sort of talk through a little bit of the differences in the syntax, but they're very similar. Okay. All right. So first, I want to review Lab 3. So let me switch my share over there. Okay. So here we are. This is Lab 3, and this had multiple parts, right? So the first was the foundations, and first question was briefly name and describe the 3 fundamental components of a function. So this is the formals, which are the arguments applied to the function, the body, which is basically the guts of the function, everything that is actually happening within it, and then the environment, which is where the function lives. Okay, so we talked about environment probably for most of the work that we do. It's probably a little bit less important than the body and the formals, which are both obviously super important. Okay, but the environment does become important when we're thinking about programming with dplyr, because that's where non-standard evaluation comes in, etc. Okay, any questions on that? All right, so then the next part is describe 3 different ways functions can be stored/applied, and an example of when you might want to use each version. So the first is anonymous functions. So those are used usually within what are called functionals, like lapply or per map. So this would be, with map, this would be the tilde and then the .x. That's essentially an anonymous function, right? But with lapply, it would be writing function x and then x plus 3 or whatever. That's an anonymous function because it's not bound to a name. It exists only within that loop and then it's gone, right? So that's an anonymous function, and you would use those within functionals like map or lapply. The typical way that we apply functions is we bind them to a name, okay? And so like lm, for example, is a function that is bound to the name lm, all right? And so this is typically how we apply these functions. All anonymous functions could be bound to a name and then loop through by calling the name that it's bound to, or you can apply them anonymously, right? But typically, we bind a function to a name. And everything that happens in R, anything that does any sort of operation in R is a function, and they're usually bound to names, okay? And then the final one is that functions can also be bound to names and stored within lists, okay? So you can have a list of functions, and it's easiest if they're bound to names within the functions, but they could just be list objects also. And then if you do that, then you can actually loop through that list of functions to apply all of those functions to a single vector, all right? So this is sort of a little bit backwards from how we typically think of things. Usually we think about looping through a vector to apply a function, but you can also, if you have a list of functions, you could loop through the functions to apply each function to a vector. Okay? So those are the three main ways and why you would use them. Questions on that? All right, moving on to the applied practice part. So first, I said the mean is defined like this, right? And that basically means we're going to sum all the stuff and then divide by the number of things there are. All right. So I said write a function to calculate the mean that removes missing data before conducting your calculations. And then you can't use base mean to do that. Okay. Include a warning message in your function if missing data were removed that prints the total number of cases that were removed. Okay, so this means inside your function, you're going to first have to check if there's any missing data. If there is, then you're going to want to count how many of them are missing, report that through a warning, and then remove that missing data and then calculate the mean. Okay, so this is how I did it. And of course, there's more than one way to do this. But let's see, is there anything up here I need to run? No, there's not. Okay, so I just said function x, where x is just going to be a numeric vector, right? And the first thing I'm doing is I'm saying if any is .nax. Okay, so we didn't ever really talk about the function any. There's other ways that you could do this, but any is going to look through a logical vector, and it's going to test if any of those elements in that logical vector are true. If even one of X number of them, so say you have, 47 trues and falses. If even one is true, any will return true. It will only return false if they are all false. Okay, so I'm saying is.na on X, that's going to return a logical vector that's the same length as X. Okay, so if the vector I'm giving it is 432 elements long, right, then this will return a logical vector that's 432, length 432, okay? And then it's going to say, are any of those missing? And if yes, if that's true, then the first thing I'm going to do is I'm going to calculate the total number of missing data. Okay, so now rather than asking are any of them NA, I'm just going to sum the NAs. And this works again because we're going to coerce the logical vector to integers where trues are 1 and false are 0. Okay, so this will sum all of those, give me the total missing, and then I'm going to throw a warning that says tot NA, observations removed due to missingness. Okay, and then finally, I'm going to redefine X where I'm going to na.omit X. Okay, so if there's missing data, X now has missing data removed after it's thrown the warning. Finally, then, I'm just going to return my mean like this by saying sum of X divided by the length of X. Okay, and it's important that you do this in this order because if we're calculating the length on the full vector and not the na.omit vector, then our mean is going to be wrong, right? Because we only want to calculate the mean on those not missing values. Okay, so I'm going to run that, and then we're going to next test this function to make sure it provides the expected results and gives identical output to base mean when na.rm equals true. Okay, so I'll do my mean on empty CarsMPG and call mean on that, and you can see they are exactly the same, so that's good. Now, if I call it on ozone, it gives me 42.12931, and I get this warning message. In my mean, 37 observations removed due to missingness. Okay, so I can call mean on that with base, and I get nothing. If I call mean with na.rm equals true, now you can see the values are the exact same. Okay, so that's pretty good, quick check that my function is doing what I expect it to do. All right. Any questions on that? Okay. The next part was to turn these 3 lines into functions. Okay. And as I mentioned, I wasn't looking for you to extend these in any way. I was just looking for you to turn these into functions. Okay. And this part's fairly important. Make sure to give them meaningful names. Okay. Ideally, that would be verbs. I actually think one of my names here is fairly poor, but it's what I chose at the time. Okay. And I would never dock points for the name that you give a function, but it is worth thinking about what you name these functions. So if you come back to them later, you know what they're doing. And for sure, if other people are going to use them, they know what they're doing. Okay. So first, this is just going to count the number of missing elements in a vector. This is going to give the proportional representation of each level, unique element in a vector. Okay, so if there's 5 levels, it'll tell you this first level has 10% of the data. This second level has 33% of the data. The third level has 2% of the data, and etc. Okay, and then this one is just going to normalize or z-score a vector. Okay, so this is how I did it. For this one, I called it just prop missing. Oh, this is different. I did a different thing here, apparently. So this is the total number missing. So this should probably be count missing, all right? And then this should be sum. All right, so I'll call that count missing. And then here, I'm going to call count missing when I know I have 25 missing observations out of 100. Okay, so when I call count missing, it'll give me 25. And similarly here, count missing, I'm going to test it when I know I have 42 missing, and that's what I get. Okay, so that's good. This is the one I said the name could probably be better. I called it prop cat. I don't know what a better name would be. Maybe prop represent or something. I don't know. So this could be improved, but I couldn't think of anything. So that's what I'm doing here. Prop cat. Basically, all I'm going to do is just like this one. I'm going to swap out this thing, mtcar_sil in here, with cat v, a categorical vector. Okay. And now here I'm creating a thing that has A, B, C, D, each represented 25 times. Okay. So if I call prop cat on that, I get each of those are represented evenly, 25, 25, 25. Okay. In this case, now I'm saying rep letter 1 50 times, rep letter 4 and 5 each 25 times. Okay. So now I get A is 50% of the observations, D is 25, and E is 25. Okay. So these are just like really quick tests to make sure I'm getting back the proportion I would expect. And then made the proportions easy to figure out on my own because they're just out of 100, right? Does that make sense?
I have a question about that.
Uh-huh.
So when you do split and then you say cat_b and cat_b, how does that work? Because those are the same vectors. I was sort of confused as to, yeah, when I was thinking about this.
Yeah, so we can do it like, we can test this part like this. Here, let's take just this vector. Okay, I'll just call it V. Okay, so V is just ABCD 100 times, right? And so what we're going to do is it's going to split this thing according to the unique elements of that thing. Okay, so if I do V, V, then I get a list where each of them are represented like that. Okay, so that's why when I'm up here, I'm saying, okay, this is the first part, right? And I'm going to loop through that and divide it by the length of it, of the entire thing. So now we would say, okay, what's the length of V? It's 100. Okay, so I'm going to say basically map through split V, and we'll say dot x divided by 100. Right, that's basically what's going on. what's going on? Oh, I need to do per. Oh, no, that's not right. I need to say, what am I doing here? Oh, yes, okay, that's right. So I'd need to say the length of dot x. So then when we're looking at this thing, we're saying how many elements are in this one, and we're going to divide that by 100. Does that make sense? More sense?
Yeah, that helps. So basically, you are like splitting the vector by the same vector. So
yes. So basically, each unique element will be put in a list element that has only those ones in it. All right. Okay.
thanks.
Yep. All right. Last one is a standardized one. So it looks like this, and I did extend this one a bit. You didn't have to do this by any means, but basically I wanted to, rather than just removing missing data, I wanted to do the same sort of thing that we did with my mean. Okay, so I have x, if any is .na, sum is .na, paste tot na. Okay, all of this is exactly the same as before. And this is a good example of if this is something that you need to do across a number of functions, then you should make that itself a function, right? So I could very easily have done something like this, where I would say, maybe I would call it report missingness, right? And then I'd say function x, and I'd put that in there, and then return x. Okay, so it's going to return x with it, except then I'd have to say maybe fix missingness or something like that. Okay, and then it's going to remove the missingness, but it's also going to throw that warning. And then here I could say fix missingness x, and I could redefine x as that, right? And then I could standardize to do the rest. Okay, so this is a good example of, now I have this function. I would use that function, not like I wrote it here, so I'm using it in this standardized function, but I would also use that in my mean function up here, right? So I would replace all of that with this fix missingness, just like this. Okay, so that's an example where I'm using the same thing across multiple functions, and I'm probably making my function a little bit easier to read by refactoring it like this. Okay, so now I standardize, and now I'm just going to cbind, where I'm saying I'm using the base scale function to test this. Okay, so if I say scale, that's going to by default do the exact same thing that we're asking it to do, right? It's going to divide by, or it's going to subtract the mean and then divide by the standard deviation. So I'm going to use my standardized function, and I'm going to cbind it with the na.omit version of the scaled version of that. Okay, so I get this warning message when I use standardize because of the way that I wrote it. And then we can just really quick double check that the values look all the same, and they do. And we can also test that by saying, is test standardize 1, right, this vector from my standardize function, identical to test standardize 2, which is the one from scale, right? And we can see that yes, they are. That is true. Okay, so that's a good way to check that one. Questions on that? Okay. Then we're going to write a function that takes data as its input and returns a data frame with only numeric columns as its output. Okay, so I went ahead and extended this a little beyond that as well, just to be a little more sort of complete in my function writing. But this is totally not necessary. It's just for additional examples as we're going through this. Okay, so I'm calling this df numeric. I would probably, in fact, I'm going to change it right now. I'd call this like extract numeric df instead, right? So extract the numeric columns from a data frame, basically. Okay. the function is going to take df as its first argument, and then it has a second argument in this case, which wasn't the part that's not required, which I'm saying as Tibble. Okay, and I'm setting that to true. So by default, you don't have to supply that argument. And if you don't, it will return a Tibble. But you optionally could say as Tibble equals false, and it will return a standard data frame. Okay, so here's how this is going to work. When I'm testing functions like this, I tend to like to do things like this. I just create a object that has the same name as the function argument. Okay, so I'm going to create something called df, which I will say is penguins, penguin. Is that right? Or no, it's Palmer penguins. I think that's right. Yeah. Yes. Okay. So here's the Palmer penguins data frame, right? So the first thing I'm going to do is figure out which of these columns is numeric, right? So all I'm going to do is call map LGL, map logical, on my data frame and say is dot numeric. So now I have a logical vector here, okay? And it's named, and it says species is not numeric, island is not numeric, these ones are, sex is not numeric, and year is, okay? Then I'm saying, okay, as Tibble. If as Tibble is true, then we're going to return, and notice this is an early exit for the function, so it's not going to do whatever else comes next, right? So we will say return, exit the function early, and say Tibble Tibble as Tibble df num, okay? Otherwise, just do df num. And I'm realizing as I'm looking at this function, this is not going to actually work because this is still going to return a Tibble because I fed it a Tibble. So if I have as Tibble as false, I probably want to make sure this is a data frame. So I'd actually probably should have had this as data.frame on there. Okay, so then it's an actual data frame. Okay, but either way, now we're just saying give me the numeric columns from the data frame. Okay, and if as Tibble is true, it will return this part, and if not, it's going to just skip that and it'll do this part. Okay, so now we can test this, and I'm going to call a different data frame. Let me get rid of this now, and I would actually probably say rmdf. Okay, and now I'm going to use a different data frame, this GSS cat one, which looks like this. Okay, and it has some numeric and some not. And then I'm going to call df numeric on it. And oops, could not find it. All right, let me rerun that function. Oh, because I didn't call it df numeric. Yes, it's extract numeric df. I forgot I changed the name. Okay, so then we can do that, and we get just the numeric columns in return. Okay, and then here I can say as Tibble is false, and I get a data frame instead. This is why I don't like data frames. All right, there it is. Okay, any questions on that? All right, the last one is not nearly as complicated as I made it. Okay, so I want to make sure that I preface this with that. But I made it more complicated because I think it's a good example of sort of like how I would actually probably write this function if I were writing it for a package that I thought lots of people were going to use, or at least some people were going to use. Okay, so that's the sort of approach I took here. So it says write a function that uses this function and returns a data frame with the mean and standard deviation of each numeric column. Okay, if columns are omitted because they are non-numeric, print a message stating the specific columns that were not included. Okay, so what I did here is I first used this function from purrr called quietly. Okay, quietly is very similar to safely. The only difference is it will return everything. Okay, so so just like safely will return the output and the error, if there is one, right? It's always going to return a list with two things, output, error, and one of those two things is going to be null. Quietly is the same way, except it also will include warnings and things like that, okay? So if I use quiet my mean, and I say ozone, or wait, air quality ozone, right? This is the output I get. Okay, so I have my result, output, warnings, and messages. Okay, so this is how it's going to work. It's always going to return a list of length 4 with the result, output, warnings, and messages. And the reason I'm doing this is because I'm going to use my mean that I had up above, and I want to capture those warnings. Okay, so here's how my function is going to work. I have df and my tibble again. So I shouldn't have removed my df object, I guess. I'll do this again. Create df Palmer penguins. Okay, and then this is going to be extract numeric df. Okay, so here's my df num. This is just for Palmer penguins now, right? And then I'm going to first calculate my mean. So I'm going to just map through my df num and use quiet my mean rather than my mean. All right, and what you did is fine either way. You could use base mean even, and that would be fine. But now it looks like this. Okay, so for year, the year column, we have our result, output, warnings, messages. For the body mass message for body mass, we have messages, warnings, output, results. And for flipper length, we have all of these same things. Okay, so for each column, we have a list of length 4. So we have a list that is the same length as the number of columns, and each of those elements of the list has its own list of 4 things, which are the result, output, warning, and messages. Okay, again, this is much more complicated than I would have expected you to do. All right, now what I'm going to do is I have this means list. I'm going to loop through it and grab the warnings. Okay, I say .default is equal to NA character, meaning if there's nothing there, just give me NA in return. Okay, so my warns now looks like this. Here's all my warnings. Okay, so for bill length, I get 2 observations removed, bill depth, 2 observations removed, flipper length, and body mass, 2 observations removed. But for year, I don't have anything. Okay, now I'm going to do some basically a little regular expression here. So let's see, what am I doing here? Okay, so I'm saying this is a digit plus a space and then everything else. Okay, and so then this is the, I don't know why I have this 0 there. Let's see what we should do it. Let's see what happens. Yes, okay, so it just says observations removed due to missing this. So I'm actually peeling off how many observations were removed. If we wanted to, we could capture just that part as well. Okay, but the reason I'm using this fairly complex regular expression here, it's not like the most complex, but it's, so this D means, so this means start, the caret means start, this means a digit, a plus means maybe there's more than one digit, and then this is saying a space, and then the O is for observations, right? The start of observations. And then it's saying everything else until the end, okay? And so then I want, rather than O for observations, I want a capital O, and then this //1 is saying everything else in here, okay? Regular expressions are really helpful, but they're really freaking complicated too, and it takes a long time to get used to them. So if that's like total gibberish, don't worry about it. But the point is, I'm removing all of that so that, because each one might have different number of missingness, and maybe I want to actually report it for each column, but in this case, I'm just saying there were observations removed, and I'm just going to omit how many were removed for each of them. Okay, then I'm just gonna say, okay, give me just the unique ones, just the unique warning messages. And so now I just have one warning message, which is observations removed due to missingness. Okay, then, so that's my means. And now for my standard deviations, I'm just gonna do the same thing, loop through dfnum, apply the standard deviation, remove missing data. So I'm using the base standard deviation function. There's that, okay? Now I'm saying I have a condition. If the length of the names of df is not equal to the length of the names of dfnum. In other words, I have this dfnum thing that is a subset of df if there's any columns that are not numeric. Okay, so I can check this right now, right? What are the names of df? And what are the names of dfnum? Okay, and are they different, basically, is what this is going to say. And yes, they are, because we removed some of the, like we removed species and island. Okay, so those columns were removed. So I'm saying message, the following columns were not included in the summary. And then I'm using this set diff thing, which is like a set operation thing. It's like Boolean logic. There's many ways that you could like drop the ones that are not in common between the two of them. But this is how I did it. Okay, so we do set diff on names df and names dfnum. That'll give me just the column, or just the characters, vectors, the elements in df that are not in dfnum. Okay, and so I'm saying paste that with a collapsing with a column or a comma. Okay, so that'll be species, island, sex. And then the message will end up looking like that. The following columns were not included in the summary, species, island, sex. Okay. If the length of warns is greater than 0, then we're going to warn with our warns, warning message, observations removed due to missingness. And then if as Tibble there, otherwise data frame there. So notice I'm just creating a Tibble, a thing I'm calling Tibble, TBL here, where the variable is the names of the df, and then we have the mean and the standard deviations. And then finally, we end up returning TBL. Okay. I don't know why we have a mean list there, though. That should probably not be the case. Anyway, so we'll do df summary, and we get something like that. And we can do it on forcats as well, and we get observations removed due to missingness. My means should not be like that, though. Because I probably need to, yes, this is what I need to do. So means looks like this. Yes, so I need to pull the result. So I need to say means, oh, I need to do this after the warn, so that's probably why. So we'll go means is equal to per map double, and then I'll say means, and then give me the result. Right, that should work. Yes, okay, and now, there we go. Okay, does that make sense? I mean, I know that's super complicated, but the base of the function should be pretty similar in terms of calculating the means, calculating the standard deviations, right? Looping through the data. So your function, what I would have expected from your function, is first do something like this, then loop through and calculate the means, then loop through and calculate the standard deviations, and then return a table that has those things like that. Okay, and then somehow figuring out to say these columns were not included in the summary. All right. So that is it. Any questions on that? All right, let me ask one other question. When going over something like this, and this is probably less for you all now because the term is almost over and more for the next time I teach this class. Is it helpful for me to make the function more like realistic for a package like this when I'm making it more complicated, or is that just confusing and I should just do exactly what I said in the thing?
I personally like it because I get to see functions that I never used before. That's just me.
Okay. Other thoughts? All right. Good.
I was just back chatting with Joe about the same thing, Daniel, that not only do you explain the homework, you extend it to something beyond the learning. So it's another strategy for extending learning beyond. I mean, if you spend so much time struggling through the homework and then you get the homework, but then you also there's other ways to do it. There's not just one way to do it, and there's an extension on it. So I kind of like it.
Okay. Thank you. Yeah.
I really like it too because yeah, I just learned about safely and any and functions like that, which are so simple to get at. And I tend to watch these videos at least a couple of times as much after the class. So that also helps a lot. And I know that these are out there for me to go and refer to.
Good. All right, so I will continue to do that then. I just worry a little bit sometimes that it's like, well, we were only supposed to do this part and now we're doing this stuff that's more complicated, and why are we doing this? But it sounds like it's helpful at having the desired effect, so that's good. And yeah, as if you want to check in with me on any of this, or maybe I could also give you, you know, here's a base way to do it that's exactly the question, and here's sort of an extended version of it. Maybe that would be ideal. But there was something else I was going to say here, but I forgot what it is. So, all right. Any other questions or anything anybody wants to check in on before we move to the slides for today? Okay. Also, today, your peer review is assigned. So if you come to here and you click on tags, you can see peer review is there, and then there's peer review assignments. So here's where I need to update this still. I'll push this in a minute. I have that link, I just haven't updated it. So here's each of the groups and then the repos to them. And like I said, I'll get that one fixed right after class. And then down here is your name and then the groups that you're assigned to review. Okay, so this is just like last term. Please just go to that group. So here's a group number and your groups that you're supposed to review. Go to their repo, fork it, conduct your review, and then submit pull requests. Okay. Ideally, you know, your review would be as complete as possible. I recognize everybody's at different stages of this thing. So if you're not super far on it, that's okay. But try to give as much feedback as you can. Okay. The other thing is, I know we're all super overwhelmed with coursework and the end of the term and life. So I would say limit yourself. You have 2 reviews to do. Limit yourself to about an hour per review. Okay. If you can do it in less time than that and you feel like you can do a thorough job, great. But try to not spend more than an hour on a review. Okay. And that's like an hour of like concentrated time, right? Not an hour of like messing around and going back and forth between things. Like, but if you get much beyond an hour, then go ahead and just say, this is as far as I got in an hour, and move on. Okay? Does that make sense? Okay. All right. So, question at all before we move on? All right. So basic Shiny. What I would like you to do, I'm going to give you 3 minutes. Go ahead and create a basic Shiny template just like we did before. Okay. Then I will do it as a demo. the way that we would typically do this is we would say, okay, give me a new package or project, right? And we would say in a new directory, and we want a Shiny web application, okay? Again, I'll just do it on my desktop and I'll call it new app, whatever, okay? We create that project and we end up with this app.r with this new app.r proj here. When I open up app.r, you can see I have the UI and a server, and I can go ahead and run that app and it works. Okay. So let me put my share like this. Okay. So now we have the UI, which defines the look and feel of the user interface. All right. We use it for sort of two things. We use it to define where the output from the server lives, sort of in our graphical interface, and what the inputs should be for the server. Okay. So in this default case, we have a slider input right here, which is defining the bin width for our histogram. And the label we're giving it is number of bins. It takes a minimum value of 1 and a maximum value of 50, and it starts at 30. Okay. We access these values through the input, basically list object-like thing, okay, which is here. And this thing is called bins because that's what we called it up here. Okay, so when we define these things like this, we define them with a label, and that label is then attached to the input list thing, basically. Okay, and it takes whatever values we can give it here. All right, and they come down here. Okay. The server down here takes the input from the UI and it processes it to produce some sort of output. Okay, and we can mostly just use normal R code here, and we just use that input to essentially sort of swap out what the values are that are being supplied to that. So that's part of the reason why we waited to introduce Shiny, is because this is similar in many ways to a function, right? The input is being supplied to R code, which is being swapped out interactively, but it's processing like arguments to a function, basically. Okay. That thing that we're creating, whatever it is that we're creating, we store it in as a element of the output object. Okay, so here we have output and we're calling it dist plot. Okay, and that dist plot then goes back up to the UI, and we say, where do we want that dist plot to live? Okay, and in this case, we're saying in the main pen. All right. The other thing that's very important, and this is part of reactivity that we'll talk about more later, but is we have to use render plot here. And if we had text output, we would use render text. And then up here, or whatever other output, render table. Up here, we have to specify the type of output. So plot output, text output, table output, etc. Okay. So let's change the input. Let's switch from a slider to a drop-down menu. Okay, so I want it to have all the same values that it has right now. We're saying 1 to 50, starting at 30. But instead of being a slider, maybe I want it to just be a drop-down menu. Okay, so how would we do that? Even if you don't know the specific code, what would we change and how would we change it? Let's start with what would we change? What specifically would we change to do that?
Probably the slider input in the UI.
Yes, that's exactly right. Rather than having slider input, we would have something that specifies we want drop-down input, right? And so in this case, that drop-down input is going to be called select input. Okay, and so you can follow along. But if I go select input and I look at the help documentation for it, it will say we have an input ID, which we're still going to call bins. So I'm going to change this to select input. Okay, and then we have a label. I'll still keep that at number of bins, but then we're going to have choices. Okay, so this is sort of like the radio buttons that we had before. So I'll say choices equals 1 to 50. Okay, and then we also have a selected that we can use. So I'll say selected equals 30. Okay, now I'm going to actually try to run this thing and see what it looks like. I'll open it up and we have non-numeric argument to binary operator. Okay, so that's unfortunate. Oops, close that. Sorry, I'll close this too. Okay, so we can try. I've already done that for you, but it doesn't work. Why doesn't it work? Any ideas? Let's run it again and look at that warning message a little bit closer. Or not warning, error message. Non-numeric argument to binary operator. What do you think that means? Nobody has any guesses?
We need to make it numeric, and we just got to figure out where we got to do it. So probably, I'm guessing in that histogram call would work.
Yes, we have to make it numeric. Okay, so where we're going to make it numeric is actually in the server. And the reason why is because this select input, right, is assuming that it's a categorical variable, which is a very logical assumption. If you're going to select, you're going to probably be selecting from discrete values, right? So in this case, select input probably isn't the best option for what we're trying to do, but we'll just do it anyway. And all we need to do now is say as.numeric input bins. And I think that will work. And it does. Okay. But now we have a drop down rather than the other one. Does that make sense? All right. Okay. Now we're going to move on to layouts. Okay, so tabs. We talked about this last time. Let's say we wanted a tab set that had different things. Okay, well, first, if we're going to have a tab set, we should probably have at least two things. Okay, so let's create a table that has the lower and upper bounds of the bin and the count within that range. So in other words, when we're looking at that histogram, I'm going to have a table that says what the ranges are for a specific bar, and then how many are in that bar. Okay, so this is just like a table version of the histogram. Okay, so I'm going to give you the actual code for this. Okay, so I'm going to just copy this, come over here, I'm going to bring this into here. And here I'm saying input underscore bins, not input $sign bins, input underscore bins. This is just a placeholder for whatever the input will actually be. Okay, so I'm going to just say 30. And then we're taking faithful to, this is the data that we're working with, right? The bins, I'm going to say, okay, give me a sequence from the min of x to the max of x, where the length is equal to input bins plus 1. This is exactly the code that we have, basically, right? And then what I can do is I can create a histogram where I don't actually plot it. And that just gives me the data back for the histogram. So I'm calling this H, okay? If we look at H, you can see it looks like this. And here's the mids. Here's the density. So that's going to be the y-axis, basically. Or no, it calculates the density. It counts as the y-axis. And there's the breaks, okay? So what I'm going to do is I'm going to create a tibble where I'm saying, I have to load the tidyverse. Actually, I'll say library dplyr. Generally with Shiny apps, you just like with our packages, you want to reduce the number of dependencies that you have because they can break over time because packages update just like other ones do. So if you're using other packages, it's totally fine to do that. But I probably would never say library tidyverse because that's going to load a bunch of packages. Rather than that, I would just individually call each of the packages that you're using. So I'm going to use dplyr, as you can tell down here. I'm also going to use tibble. Okay. And then that should be it. Okay, so I'll say the lower, I'm creating a tibble where the lower is a lag of h breaks. Okay, so h breaks is this thing, and the lag is just going to shift everything over 1. Okay, so we get NA for the first value, and now we have a vector that's 1 more than it was. And then the upper is just going to be the breaks. So it's going to look like this. Okay, we have this one's going to be NA, and then this is the upper bound of that. So it's like from 0 or whatever, negative infinity, to 43. That's the first bin. The second bin is from 43 to 44.76. The next one's from 44.76 to 46.53, etc. Okay. Then I'm going to drop NA because I don't really actually care about that first one. I thought that was part of dplyr, didn't? No. I loaded dplyr, right? Dplyr drop NA. Anybody know what drop NA is from? I thought it was dplyr. There we go. It is from tidyr. All right. So come back here. Library tidyr. Okay. So tibble drop NA lower. Okay. And then we're going to say counts is equal to the counts that we have. Right? So there's 1 in this range, there's 8 in this range, etc. Okay, and then mutate if is .numeric round to 2. That's actually a deprecated function, but it should still work. Or I guess it's not deprecated, it's just superseded is the term for it. But we'll just go forward with that. Okay, so here's the table that we're going to end up with. And the thing that is nice about this is this code, right? If I change this now to say 10 and I rerun this code, it's going to give me a new table that has different counts and different breaks even. Okay. So this table is going to adjust just like the histogram will adjust. All right. So I'm giving you this code. I would like you to copy that code and then try to take it from here. So use that code. And I'm giving you 8 minutes to add a table that's going to go below the histogram that has this, okay, that works just like this. Does that make sense? Questions? All right, give it a try, and then I will demo it, okay? Okay, hopefully you made it most of the way, if not all of the way. I'm going to go ahead and demo it now, how I would do this. And I've mentioned a couple times that Shiny apps can get really complicated really quickly, right? And one of the ways that you can get around that is by writing functions, okay? So that's actually how I would approach this. I would keep this all how it is, except I would get rid of this part, but I'm not going to quite yet. And then I would create a function to do all of this stuff down here, okay? So I'm going to call my function create bin table. All right. And then that's going to take a function. And the only thing it's going to take is input bins. Okay. That's going to be the only argument. Now I could make this function more general. So it takes any data frame and calculates this for any column. But I'm not going to do that in this case. Right. All I'm going to do is just the table that I need for my faithful data. Okay, so this is the data that we're working with. It's, in fact, I can have this outside of here as well. And then we'll say bins sequence, right? All of this is going to be the exact same. And because I have this as the argument now, that's going to work there as well. Okay, so everything else should just work. Now I can delete this. And when I'm going to actually, just to make sure that I have everything clean here, I'm going to go session restart R. Okay, and then I'm going to load just these ones. I'm going to make X that, right? Create bins. And now I can test it a couple times. Okay, let's say with 5. There's a table, right? Let's try with 50. There's a different table that has a lot more rows. Okay, so that's working. Good. What I'm going to do now is I'm going to actually save this. Can you see that? Yeah, okay. So I'm going to save this within my app, my new app thing. I'm going to call it funds.r, okay? Because I'm assuming that I'll probably have more functions if this was like a big app that I was creating, right? So I'm going to call that funds.r. And then I'm going to go back to my app here. And I need to change this back from select input to slider input. Slider input. And I always have to go to the help documentation because I just don't remember. Oh, and I got to load Shiny. All right, slider input. Bring this over. So we're just going to say min and max, and etc. Okay, so we'll say min is equal to 1, max is equal to 50, and the value where we're going to start is equal to 30. Okay, so that's good. And then up here, now, one of the first things I need to do is I need to read in that entire file, that funds.r file. Okay, so the way I'm going to do that is through a function called source. Okay, so I'm going to source, and I'm going to say here. Well, I'm actually not going to do that. I'm just going to say funds.r. Okay, so again, I'm going to do session restart R just to make sure things are working. And if I say source funds.r, now you can see my global environment just changed. So I have something called X, and I have functions, create functions down here. All right, but actually that X probably needs to be created. Actually, it doesn't. It doesn't matter in this case. So we're fine there. Okay. So all of this can stay as it is. Although I could for sure clean that up some as well. In fact, like one of the things I could do is delete that, but I'm not going to. Now I'm going to say output table, right? TBL down here. And what I'm going to do is I'm going to say render reactable, but I need to load reactable as well, library reactable. And this is sort of not great practice where I'm loading libraries here and here. What I'd probably do is either load them all in my funds.r one, load them all here, or have another file that's just my libraries. In fact, maybe we should do that real quick. Let's say, so let's take these here, pull those out, okay, and we'll put them here. We'll pull Shiny and Reactable out here, and we'll put them here, okay? And then we'll save that as pkgs.r packages, okay? So save that. And now in my app, I'm going to source pkgs.r and source funds.r, okay? And again, I'm going to session restart just to make sure it works. Excuse me. And then we're going to source those, each of them, okay? And notice in packages, I have Reactable loaded now, so that should be good. Then back to my server, I'm going to say render reactable, okay? Oops. And then here, I'm going to use my function, right? Which was, what did I call it? can't remember. Create bin table. Okay, create bin table. All right, and that's going to be with the input bins. Okay, then from there, what I want to do is make that a reactable table. And because I've already loaded dplyr, I can just pipe it, but I could also just wrap that whole thing in it. So I could, I could call this out, and then I could say reactable out like that, right? Or I could just pipe it to there too. Either way, I'll do it like this. Okay, so reactable output. Now up here, finally, we're going to say reactable output TBL. Okay, so this TBL is coming from output TBL, which is a reactable output. All right, so through all of that, let's save this. We can do session restart R again if we want. That should now work. All right, let's try it. Open in browser, and here is our table down here. It's a reactable table, so we can sort it, right? We can look at different rows, whatever. Let's go down to a low value. Let's say 4, right? 1, 2, 3, 4. There's the lower and upper bounds. Lower is 43, upper is 56.25, and there are 63 here. So this bar is 63 exactly, right? This bar is 40 exactly. Okay, does that make sense? All right. So the way that I did this here is more complicated, again, than I would have expected it to be the way that you did it. But it illustrates one way to make your actual app less complicated, because now this whole output table thing is just this part, right? Versus like trying to have all of this code in there. And that gets more and more the case, like more and more important as your app gets bigger and bigger. Okay, we are not doing very well on time. So we've already done that, but we have now 5 minutes left, which was when I was hoping to move it to a tab set. So I will just demo this and you can try to follow along. All right, but when we're doing this, this is now changing the UI. And this is the last thing we'll do for today. There is a script that's up there that shows how to move it to a nav bar as well. Okay, but what we're going to do is within the main panel up here in the UI, we're going to create a tab set panel. Okay, then within that, we create tab panel, and we have to give it a title. Okay, so the title for this one is going to be plot, not plot. And then we'll create another tab panel, which I'll call table. Okay, then within each of those, we put our actual output. Okay, so we say comma, plot output, table, comma, reactable output. Okay, and that should work. And it does. So here's our plot. It works. Here's our table. It works. Okay. So I'm going to pause there basically for today. If we wanted to do a nav bar, though, we would do basically the same thing. But again, I mentioned this before. The thing that is really different about nav bar page is that you have to have everything in there, okay? And you have to make sure you give the first argument a title, okay? Like the title of your entire app. And then you use separate input IDs for, so like right here, right? We're using bins, right? For both of these things down here. We're using it in the table and in the distribution plot. Those are in tabs on the same page, so it's fine. But if we were to move those to different pages, we need separate inputs, even though they're the exact same thing, okay? And when you're doing a navbar page, you want to have everything, okay? So from here, we would still have sidebar layout all the way through main panel for the first page. And then for the second page, we would have sidebar layout all the way through to the main panel, okay? So they're literally like different pages of your Shiny app. So as your Shiny apps get bigger and bigger, that's going to be a really critical feature, but it's also like gets difficult in terms of tracking all the stuff. So this is where like organization becomes really, really important. And unfortunately, it's just hard. It's just difficult to do. So there are things called Shiny modules, which you can look at here. There's also a chapter on them in the Mastering Shiny book. But just generally using functions and things like this, like I just showed, can be really helpful. And trying to refactor your code to make it as condensed as possible is really helpful as well. Okay. So that's now a basic introduction to Shiny. Because we didn't get to Shiny dashboards today, I will start with that on Monday, and then we'll talk about reactivity and things like that, okay? And then we do have one more built-in day that was sort of just, so Wednesday of next week was supposed to be kind of a review. So it may be that we just finish up the Shiny content on that day rather than sort of reviewing previous content, okay? Okay, so that's it for today. Please do get to your peer reviews. I'll fix that link as soon as we're done with class today. And otherwise, I'll see you on Monday.